Right, okay, and welcome. So we're going to do the final lesson now on applications 1.1, and this is looking at bearings. Okay, so just a quick recap. Bearings are angles that are measured clockwise from north, and they are given as 3 digits. A quick recap, the bearing of B from A would be to start at A, start north, and go clockwise until you find that angle between A and B, and that would be the bearing from B from A. If you wanted to know the bearing of A from B, that would be start at B, going north, we go clockwise, and that would be that angle. Okay, so that's a really quick recap. I want you now to take a look at this exam question. Okay, so I hope you've had enough time to read that. If not, pause this video and give it a read. So the first thing that I'm going to say is it's absolutely normal to freak out ever so slightly when you see a question like this. And I would actually go as far as saying that freaking out slightly is the most normal reaction because there's a lot of information being given to you at one time. So when you deal with a question like this, what you want to do is take it slowly and write down things that you know as they occur to you. Don't even think about the final answer too much. Just think about what you know and what you can write down. So the first thing is a yacht sails from a harbour H. So this is the harbour where the boat starts. It goes to point C, so it goes along here, and then it goes along to point D. Right, so we're perfectly happy. The yacht's gone here, then here. We've also got a dotted line in this diagram. Now, before I go on, I can see a triangle here. So the first thing I think of is angles in a triangle sum to 180 degrees. Okay, what else do I know? I know the sine rule. Okay, I know the sine rule, so I can just write down the sine rule. A over sine A equals B over sine B. So I'm just going to write that down. I know the cosine rule. Okay, I'm not going to write that here just for reasons of space, but I can look that up. I know the cosine rule, so I'm going to write that down as well. So I've just written down a couple of things that I know about triangles because these things might come in useful. C is 50 kilometers due east of H. So what that means is we've got C here, we've got H here, and this line is east, and it's exactly east. Now, if you think about a compass, not left enough space for west there, but you've got north, east, south. This is exactly at a right angle. So it's worth bearing this in mind that this angle, this big angle I've marked in red, is a right angle. And that means that this is also a right angle as well. Okay, which is 90 degrees. So that angle there is 90 degrees. Again, I've read a piece of information from the question, and my first instinct is just to jot this down in some way. So we're just going to jot this down as that's 90 degrees. We're going to get that down straight away. The next thing is D is on a bearing of 40 degrees from C. Okay, so D is on a bearing of 40 degrees from C. So that means we start at C and we go clockwise from north. That means this angle here is the bearing. That is the 40 degrees. Okay, I might use a different coloured pen now. So what we've learnt is this angle here, this big angle, which I'm going to call angle HCD, because you start at H, you go to C, and you go to D. This big angle is actually 90 degrees plus 40 degrees. That angle there is 130 degrees. Again, all I've used to get that is information from the question. I know that this is a right angle. I know that this is 40 degrees, so I can just add it up. Okay, I've got quite a lot of information written down. I'm ready to read the question. Calculate the size of angle CDH. So if I start at C, go to D, and go along to H. The question wants me to find this angle here, which I'm going to call angle X. Okay, let's think about what we know. We know that angles in a triangle add up to 180 degrees. We could use that if we wanted to find this angle here. We know two sides of the triangle and one angle. And we want to find this missing angle here. So I'm asking myself, could I do that with the sine rule? What do I need for the sine rule? I need an angle that I want to find, an angle that I know, and two sides. That looks good to me. So why don't we call this side A, and we'll call this angle A, and why don't we call this side B, and we'll call this angle B, with this 130. So what we can do is we can use the sine rule to do this. So I've said that A is going to be this 50 kilometers. Sine A, well, this is going to be sine X. X again being the value we're trying to find. B is going to be 79, and sine B is going to be the sine 130. So I think the first thing that I'm going to do is just work out this fraction on the right hand side. So on my calculator, I'm going to do 79 divided by sine 130. And I don't want to round at this point. Now, what I can do is if I times both sides by sine x, I'm just going to put dot, 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 just to save some space there, times sine x. I can now divide by this big number here. And that's going to tell me what sine x is. So again, I can just do 50 divided by my previous answer, and that's going to tell me that sine x is equal to 0.4848. 382551. Again, I don't want to round until right at the end. This decimal that I've written down here is just this fraction. I've just done that fraction in my calculator. And then if I use inverse sine function, that's going to tell me that x is equal to 29 degrees. Okay, now I've rounded that. When you work this out in your calculator, you'll see that you get 29.00, and it would just be appropriate to round that to 29 degrees. So we've got 29 degrees there, which is great. How do we do it? We wrote down all the things that we knew about triangles. We wrote down all the things that we could glean from the question, and we just went with it. And that's how you turn that panic into an actual answer. Just start writing things down that you know. We didn't even use the cosine rule, but I don't regret writing it down. We might have needed it. You know, we could have used angles add up to 180 degrees. We didn't need it, but it doesn't matter that we wrote it down. There is another part to this question. So we're going to remember that x is 29 degrees. So I'm just going to mark this on here. The next question is, calculate the bearing on which the yacht must sail to return directly to the harbour. Okay, so let's just be clear about what we're trying to find. we want the bearing. I'm going to use a different color here. I might use purple. We're going to find the bearing to sail from where the yacht currently is. So the yacht's currently here at D, and we want the bearing that goes to H. So this is the clockwise from north to H. You'll notice that this includes this angle of 29 degrees that we found, and really we've got this angle here to find, this D all the way around to this line, to C angle to find. The other thing I'm going to note on here is that this angle is 40 degrees. And that's just, we marked that on the previous diagram, if you recall. And that just comes from here. Okay, so we've marked the diagram with the things that we're interested in. Let's just have a think about what we know. And it might make sense just to draw this picture again in just a simpler fashion. So if I draw this, if this is C and this is D, and I'm going to ignore the dotted line for a second. We're going to draw this bearing here as 40 degrees. What do we know about this angle here? This angle between the bold line and D, and I might mark this with a different color. I might use green for this. I might just go back over this in green. What do we know about this angle? This angle that takes us from the north line and it comes this way. What's this angle? What word do we describe these? These are both in the interior and they're together in this interior. These are co-interior. These are co-interior angles. So this green angle plus something, plus this green angle is 180 degrees. So we looked at that last time with co-interior angles. So I'm hoping that you're going to tell me that this green angle is 140 degrees. Again, we've used just our facts about co-interior angles there. So let's have a look at what's happening at D. And again, sometimes it's useful just to draw a diagram here. What we've got is this co-interior angle is 140 degrees here. And we want to find out this sort of question mark angle here, which is this one that I've marked in purple. Again, I might just use some purple here to show this. Okay, so this question mark angle, what is this? And again, I'm hoping that you're remembering that angles around a point sum to, what do they sum to? Yeah, that's right, 360 degrees. So this purple angle must equal 220 degrees because 140 plus 220 equals that 360. We're nearly there. What do we want? We want to find this whole thing. We want to find this angle plus this angle, the 29 degrees. Okay, so if I'm recreating this D here with the sort of the dotted line, we know that this bit is 29 degrees. This is what we've worked out to start with. So the final answer must be 220 degrees plus the 29 degrees. Okay, so that's going to be a final answer of what? Well, it's going to be 249 degrees. Okay, so again, that might be quite complex. You might find that quite difficult, and that's normal. I want you to look at what I've done here, though. This diagram, I found it more useful just to quickly sketch my own diagram to work it out. I think this question is 100 times easier if you actually sketch bits of the drawing yourself, because how easy was it to find the 220 degrees? And how easier was it to find the 140 degrees when we just sketched it ourselves rather than try and muddle our way through what is quite a complicated diagram, really. Um, and again, the sort of final mark would be for adding the two together to get the 240 degrees. Quite complex, but this shows you sort of where this bearing, how difficult this bearings can go. I think I'll do another example. So again, I'll pause for a second just to give you a chance to have a look at this one. Okay, so I hope you've had enough time to read this. So in this diagram, we've got a diagram D, E, and F to represent Dunbridge, Aylesford, and Fairtone. Okay, great. What else do we have? We've got the it's 15 kilometers west of Aylesford. So this this tells us that this is a perfect 90-degree angle here. This being west tells us that there's a 90-degree angle. Stop for a second. What can we work out now that I've drawn those diagrams? Now that I've drawn those right angles on there? I'm just going to draw a D here. We know that's a right angle, and we know that the whole thing is 126 degrees. So I can actually work out just this angle here, which I'm going to mark in purple. I can work that out by doing 126 degrees minus the 90 degrees that I've marked on there. And that's going to tell us just this purple bit that I've marked here, isn't it? So 126 subtract the 90 is going to be, where are we, 36 degrees. So this is 36 degrees. Okay, great. We've not even read the question yet, and we're already well into it. What about this point here? What do angles around a point sum up to? Because we know this is 90 and we know this is 230. So what's this red angle here? Well, the red angle is going to be 360 degrees minus 230 minus 90. That's going to be the red point. And I'm hoping that we can see this, that just by subtracting these angles that we know, we're just left with this being 40 degrees, and this must be 40 degrees as well. And in fact, I'm just going to mark this angle. I'll use a different color. What's this angle? What do angles in a triangle sum up to? That's right, they sum to 360 degrees. Not 360, sorry, 180 degrees. So this is going to be 104 degrees. Okay? And again, we'd write this, we're clear to write this down. This came from angles around a point. Angles in a triangle. It's important that you write this down, angles in a triangle sum to 180 degrees, because it tells the examiners what you've done, where this 104 degrees has come from. So we're going to show our working. Okay, so we've worked this out. Again, we've not even read the question yet, and we've looked at all this information we've found, and that all this that I've done here came from this one sentence. So it's really important that you break it down sentence by sentence. You were told that it was exactly west, so we drew some right angles, and from those right angles, we just went on autopilot and found some missing angles. The bearing from Dunbridge, the bearing of Fairtone is 126 degrees. We've dealt with this sentence. We've used that 126 degrees. From Earlsford, the bearing of Fairtone is 230. Again, we've used this information. We understand it. The final thing here now is calculate the distance between Dunbridge and Fairtone. So that's just going to be this point here, which I'm going to label X. Now it's a triangle, so straight away I'm thinking about my sine rule and my cosine rule. So thinking about my sine rule, which is probably the easier of the two rules, I need to know two sides and two angles. Now, one of those things can be the thing I'm trying to find. Do I know that? Well, yeah, I've got two sides. I've got the 15-kilometer side and this x that I'm trying to find, and I definitely have two angles. So we're going to use the sine rule. So the sine rule is A over sine A equals B over sine B. We're going to call this side A, so this is going to be angle A, and we're going to call this side B, so this is going to be the angle B. And now I substitute. A becomes X, sine A becomes sine 40, B becomes 15, sine B becomes sine 100, 104. Again, I've not used this 36, and because the reason I've not used that is because the way the sine rule works, it's about the angles opposite the sides. So this angle is opposite this angle is opposite this side. Now I can work this out. I mean, I can work this out just by doing 15 over sine 104, and I can multiply that by sine 40. Notice that I've just multiplied sine 40 to get x. This is just a case of typing this into a calculator now. 15 over sine, press the wrong button on my calculator there, sine 104 times sine 40, hit equals, and that's going to give me my value of x, which is going to be 9.93698, etc. So to three decimal places, to three significant figures rather, that's going to be 9.94 kilometers. Okay. Just before I move on, I'm just going to talk for 1 second about this final line here that we didn't even look at. It says, do not use a scale drawing. What this means is, if you have a compass, if you have a protractor and you have a ruler, you could actually just draw this picture. You could do a scale drawing. So, for example, you could draw this being 15 centimeters instead of kilometers, and you could just measure these angles. And if you know what you're doing with a protractor and a ruler, you could just quickly work this out by drawing this picture yourself and then just using a ruler to measure this distance here, which, to be honest, would be a perfectly valid way of doing this and potentially would be easier depending on how you are with your trigonometry. They've just included this sentence just to make it clear that what they want to do is they want to assess your knowledge of trigonometry. So that's just a bit of a coverall just to make sure that you don't just get that compass out, get that protractor out. Sorry. Okay. There's one more example here that I think we'll do. And again, follow it along. I'm going to stop for a second to give you a chance to read the question. Right. Okay. Take a deep breath. Um, you know, take a second and let's think about what we have. First thing I do is I see a triangle and I just write sine rule, cosine rule, angle sum. 280 degrees. You know, let's put a triangle there. Angles in a triangle sum 280 degrees. I'm just going to whack all that down to start with. Um, what else do I see? Look at this B here. Just take a look at this, right? Look at this. I'm going to even recreate this diagram. And I just want you to like really look at this and sort of take this in. There's a big angle marked here, right? And this is an angle around a point. You can see, right, just 3 seconds into looking at this, my brain's telling me angles around a point sum to 360 degrees. I don't even know what the question is, but I know this is going to be useful because look at it. Look at it. They've marked a point here, and it's a marked angle, and it's going around a point. So just have that, let your instinct take over a little bit, and and I'm not joking. When you're doing your Nat 5 test, I want to see this written down. You're just going to spam out all this stuff that you know because it's going to help you deal with these difficult questions. Right. So with that done, let's just have a look. In a race, boats sail around three buoys represented by A, B, and C in the diagram below. You'll notice that boats are talked about a lot. It's because bearings are actually used in, in nautical terms when you're using boats and stuff. Okay. So what we've got is we've got B is 8 kilometers from A, which is marked on the diagram, and a bearing of 60. So we can mark 60 degrees here. First question, is there any other angle I can write down right now? Before I even move on, what can I do? Take a second, see if you can tell me anything that you've learned that's going to help you fill in a missing angle. Can you see the co-interior angles? Can you see this angle here? What does 60 plus this blue angle add up to? The sum to 180 degrees. So 60 plus 120 equals 180. So this blue angle is 120 degrees. We've worked that out before we've even done anything else. Oh, and look, our plan's coming together here. Look, we can fill in this. This is 120 degrees. Right, okay. We've dealt with this sentence. C is 11 kilometers from B. Okay, I don't need to do anything with that just now. It's marked on the diagram. And A is 13 kilometers from C is also marked on there. Part A is find the angle ABC. ABC means start at A, go to B, and then go to C. So it's this angle here at B. So I'm going to mark this as X. Okay, fine. Let's have a little look. What do we have? We've got a triangle. We know all three sides, and we're trying to find an angle. Can we use the sine rule? I encourage you, get the sine rule up. Have a look. Do you think you could use it? The answer is no, and the reason for that is the sine rule, you need two sides and two angles. Well, I'm not being funny. There's not much else we can do. It's gonna have to be the cosine rule. If you can't use the sine rule, what's left? So the cosine rule, you recall, has two parts, like two ways of writing it, and in fact you're given both in the test. One is for finding a side, and one is finding an angle. You should know that we're trying to find an angle here. So let's just write out the angle version. So the angle version is that cos A is equal to B squared plus C squared minus A squared, and that's all over 2BC. Now, you don't need to memorize this. You can just look this up. It's important that we get this right. So A is like the angle we're finding. So we're going to call this side A, and we're going to call this angle A. These two sides we're just going to call B and C, and it doesn't matter how you label these two. What's important is that you get this angle A bit right. So side A is opposite the angle you're trying to find. Now from here, you're just going to plug this in. Cos x is equal to b squared, which is 8 squared, plus 11 squared, minus 13 squared, divided by 2 times b, which is 8, times c, which is 11. That is a calculator job, and you're going to pop that into your calculator, or you're going to listen to me type it. 2 times 8 times 11. Right, I'll pop that into my calculator. I'm going to check that I've got it right. That gives me 1. Where's my pen gone? There we go. 1 over 11, so 1/11th. Okay? So to find x, I'm just going to do shift cos 1/11th, and that's going to tell me my angle, which is going to be 84.78409,143. So that's going to be, to three significant figures, 84.8 degrees. Okay, just by the way, take a second and check that angle makes any sense. Does this angle look like it could be about 85 degrees? Yeah, it's nearly at a right angle. So it looks like that could be right. Right, okay. The next part of this question, by the way, I've missed off just for reasons of space. But the question is find the shaded angle. Okay, and that's just what part B says, find the shaded angle. Or it says hence find. Well, look, we've done all the hard work. Look at this diagram here. We know what x is. We know x is 84.8. We know that this is 120 degrees. So angles around a point sum to 360. So the shaded angle is 360 degrees minus 120 minus 84.8. And if you do that, which I'm going to quickly do, minus 120 minus 84.8 is going to be the shaded angle. So I'm going to write it here, is 155.2 degrees. Okay. And notice how easy that second part of the question was because we'd already written down all this stuff. Again, use what you know. If you see two co-interior angles, work the one out that's missing. If you can see angles around a point, work out a missing angle. And if you can see a triangle, for goodness sake, start writing this stuff down because the chances are you're going to use one or several of these. Okay, so that's everything. We've looked at bearings. You can see, I hope you understand that bearings really incorporates the entirety of this topic. So the sine rule that you've learned, the cosine rule that you've learned, that all crops up within the bearings. The task now is just to go through and practice and practice and practice. As you can see, there's no one general rule, one easy, quick fix way of solving every single question. You've kind of got to suck it and see, I'm afraid. But what I hope this video has shown you is that the way to get through these questions is just do what I've done and kind of muddle through it. See the question, write down anything that you can tell me straight away. Any knowledge that you have, try to apply it, and a question's going to pop out. You know, at the end of the day, there's only so many skills that you get taught at National 5. The sine rule, the cosine rule, the angles, the co-interior angles. You only get taught so much. So at the end of the day, if you try these different things out, you're going to get the correct answer because that's what the test is testing you on. There's not going to be some sort of secret way of solving the question that is something you've never been taught. So that can sometimes give you a little bit of confidence. Suck it and see, and an answer should fall out eventually. But the way to get there is to practice, practice,